Oh, oh, check it out.
We first started our assignment deciding what bridge we were going to build. We looked at different styles of truss bridges, including the Warren truss. When designing, the group decided on a modified Warren truss with vertical supports. We drew the bridge out on paper at a scale of 1:1. This way, when it came to cutting, we could cut members directly to size. We first started cutting members to size using scissors and Stanley knives. The bridge had to span over 350mm and be no more than 80mm wide. It could not weigh more than 200 grams when tested. We used the Selleys quick dry superglue, which was specified in the assignment task sheet. We then began by gluing members together. When doing this, we would tape the middle of the member and then superglue the ends of the member. After this superglue had dried, we would then take the tape off and put additional glue in the middle of the member. We then began gluing the truss members together, and we found that a bit of styrofoam, we could stick the spaghetti into it and then glue it, and that way it would hold. Once dried, we could then take the truss members out, ready to be glued to the bottom of the bridge. We then started off by gluing the bottom members to the bridge, then followed by the top members. As we were testing the first bridge at home, we came up with a method in which way we would test the bridge. This method involved getting a bucket, then attaching the bucket to the middle plate of the bridge with tie wire. We could then load the bucket with weight and test how much it was going to hold, roughly, before our final test. The total weight of our first bridge was 130 grams. When it came to testing, we would fill cups up with sand and weigh them, so that every cup was of 500 grams. This way we could keep track of how much weight the bridge was holding. Our prediction of our first bridge was that the members would break in the middle. This is shown in the computer software that we have used.
Keep the recorder then. Oh.
It's taking the wood. Oh, damn it!
Our first bridge ended up holding a total of 6 kilograms. When designing and building our second bridge, we decided to simplify our plan to make it more easier to build and construct, and therefore we could strengthen members and make it a lot more stronger in places where it broke. Our design was still a modified Warren truss, but it had no vertical members in the middle section. Shown in the computer program, it was to break in the middle most easiest. Where it was most likely to break, we decided to add extra members of spaghetti in these areas with more glue, that way it could hold more and be less likely to break in these areas. We began using the same method, cutting spaghetti and gluing them on plywood board as we did with the first bridge. We started by first constructing the base of the bridge by gluing members together. We then made the top of the bridge, doing the same method as we did for the base. Once finished constructing the bottom and top layer, we then measured them out to our drawing to make sure that they were the right size. When making the truss members, we found a method using Gladlock and spaghetti, which we could make these round cylinder members very easily. What we would do was get the spaghetti and put dobs of glue onto it. We would then get the Gladlock and roll it up into a cylinder form. As the Gladlock did not stick to the spaghetti, we were then able to unravel it and then cut our members back down to size. Once members were cut to size, we would then sand the ends of them so that they would fit perfectly when the truss was put together. To hold it all together whilst gluing, we used paper tape to hold all the members in place while we would glue. Here is the finished product of our second bridge. When testing our bridge, it weighed 89 grams. Here's the final test.
It's on video, man.
Hasn't started yet. Nearly. Still 0. Haven't started.
Should that be in the middle more? Should we push that across? Yeah,
Yeah, but there's no load now, so you can put, yeah. Okay. Yeah, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, wow, 14 kilograms, not bad.
In our final test, our bridge held a total of 14 kilos. It broke in the middle section, not where we expected it to break.